Creating 3D is more than just modeling and geometry. Just as important is the look and feel of the model. Your models could represent smooth metal, glossy glass, rough stone, or even transparent glass. This is determined by what we call the material of your 3D objects. Shapes can express a style, but materials allow many more creative possibilities. In 3D, a material is set by two different things: the material properties and the shader. A material is defined by a unique set of properties that determine its specific look. A shader is what turns the material into something actually visible. It is usually part of your 3D application and can be easily exchanged between programs. While sometimes the terms shader and material are mixed, it's best to think that the material is the look you define for your 3D, while a shader just provides a framework for you to work within. There are many shaders and material approaches. Some are realistic, some are stylized. These days, physically based rendering, or PBR, is a common system that provides a flexible and universal approach. It's available in many applications. We'll summarize some of its most common properties. There are the color, reflection, surface height, and transparency groups. A material's color is the simplest and most obvious one. Usually called diffuse, albedo, or base color, it represents the color of a material without light, shadows, or reflection. In most cases, it's obvious what this color is. Red plastic, gray paint, or brown wood, for example, are all easy to see. Materials also define how a surface reacts to light. If a material is glossy and smooth, it will have sharper reflections and highlights. If a material is rough, it will have a matte, dull appearance. Advanced reflection controls even let you tint the highlights like chrome or metallic paint. In real life, some objects have imperfections and small surface variations that are impractical to model. Like a grain or dents and scratches, it is easier to fake these with a material instead of using millions of polygons. This property is called normal because it modifies the normal of a surface, but can also be done with bump or height properties. These let you fake the look of small geometric details on your material's surface. Sometimes, the line between geometry and material is blurred, and your material displaces the geometry itself without the need for modeling. The last group of material properties is for materials that let light pass through. We call this translucency, which literally means shine through. You might also encounter the terms opacity and transparency. Opacity and transparency are non-realistic behaviors. In reality, most surfaces exhibit translucency, like glass, plastic, and water. They are solid, but light passes through them. There are some specific translucent behaviors with additional properties, like refraction for colored glass or light scattering under the surface of a wax candle. To summarize, opacity and transparency are used for creating things like cutouts with surfaces being completely invisible, while translucency is useful for creating real-world materials. Which of these property types are available depends on the shader and how it's implemented in your 3D application. Some programs will only have one main shader that supports as many features as possible. Some will split more exotic features like human skin or multiple coats of paint into separate dedicated shaders. If you create your materials in a PBR system, there's a good chance they can be transferred or at least converted to other applications. Apart from defining the look of a material, you also need to assign materials to specific parts of your 3D geometry. Materials can be assigned to an entire model at once, to specific sections of your geometry, or even to individual polygons and triangles of your mesh. There are two ways to set up and assign materials to your geometry. You can make simple uniform materials by setting a few values with sliders, for example, shiny red plastic, smooth chrome, or dull paint. You then assign materials based on your geometry, which implies doing your modeling with material assignment in mind. You might want to use repeating patterns instead of uniform values, or to have unique details like scratches, worn paint, or dirt. You'll then have to make use of bitmap files or textures. These textures can either be reusable, repeating patterns, or unique to your model with specific detail matched to your geometry. You will need to prepare your mesh for this in 2 extra steps called UV unwrapping and texturing, which we'll talk about in the next videos.